Since our founding in 1978, FLOREX Insulation Company Limited has been developing various chemicals and equipment to remove and prevent scale and rust in cooling water systems. Our inventions have proved to yield good and apparent effects. Electronic Descaler. To aid environmental protection, we have developed a pure physical electronic descaler. It has passed CE marking and been granted several Taiwan and German patents. The electronic descaler utilizes special processing technology to effectively collect metal oxide in the system with the cathode net and decrease the chance for limescale to accumulate in the system. When it is applied to an old system, the electrode generates small water clusters to help remove the rust and limescale, and afterward collect them with the cathode net to reduce the obstruction. To remove limescale in cooling systems, chemicals and manual cleaning were often used. In this way, the operation of cooling and production equipment has to be halted and the capacity was reduced. Working theory. Normally, water is large water clusters composed of water molecules. Under the effect of high-frequency electric current, the electrodes on the two sides switch their polarity periodically. As oxygen is drawn to anode, water molecules move to and fro rapidly between the electrodes. Additionally, cathode draws hydrogen in water molecules, and thus electrolysis of water occurs, and some water molecules decomposed into oxygen and hydrogen. Initial oxygen is released, and hydroxide is preserved in the water. Some oxygen and hydrogen combined into small water clusters in free state. The NMR result shows that, after being processed by electronic descaler, normal water becomes small water clusters and could seep into limescale and soften and dissolve it. The electronic descaler significantly decreases the oxidation reduction potential of the water and rearranges its molecular geometry, generating small water clusters that could dissolve limescale. And in the circulating process, dissolve oxide to prevent the buildup of limescale. Through special processing, the electrodes suck limescale in the water to the cathode net. A comparison of cathode net before and after the descaling process. Application. Buildings with central air conditioning. Hospitals. Injection molding machines. Plastic extrusion machines. Air compressors. Evaporative condensers in frozen food factories. Electronic factories. Laser cutting factories. Telecommunications. Installation and maintenance. First, plug in a 220-volt single-phase power and the electrode. Place the electrode into the cooling tower basin. Turn the switch to on. The power indicator will light up. Then, turn the control knob to descale. The machine will operate automatically. When running, the electronic descaler collects limescale in the equipment like a tireless cleaner, allowing systems to always operate in good condition. After a few days, turn the control knob to stop. Turn the switch to off. The power indicator will go off. Then, take out the electrode from the cooling tower basin limescale sucked to the cathode net will be clearly visible. Cathode net cleaning and changing. To clean the cathode net, first, remove 6 screws on the top. Remove 2 screws on the bottom and a screw fixing anode electrode. Then, carefully open the net. Usually, limescale now becomes pulpy. Use plastic or rubber scraper to remove limescale from the net. Most limescale can be removed using this approach. If further cleaning is desired, make a well-mixed 1 to 10 solution of cathode net cleaner and water and soak the net in it. The limescale will be dissolved rapidly. There will be carbon dioxide gas released in the process. The cathode net will be thoroughly cleaned after 20 to 30 minutes. Wear rubber or latex gloves when taking out the net. Rinse the net with water. Fit back the cathode net. Fix the black anode with the screw. Fasten all the screws. Place the electrode back into the cooling tower basin. It can be reused. Case history. Application in a University of Technology. 900 refrigeration ton cooling tower. The electrode was placed in the cooling tower and 11 days later, a considerable amount of limescale was sucked to the cathode net. Application in a plastic factory. To prevent the accumulation of limescale, they used soft water as makeup water. But with this approach, there was iron oxide rust in the cooling water. The electronic descaler was therefore applied, and 4 months later, water in the pond became clear. Rust sucked to the cathode net was clearly visible. Application in a laser cutting factory, specializing in laser processing and producing spacers. 50 refrigeration ton cooling tower. Before the electronic descaler was applied, plates of the chillers have to be removed to allow manual cleaning every 3 to 6 months. As laser machines were acquired at different times and of different models, sealing sheets were different, and their replacements were sometimes no longer available in the market. As a result, trimming was often required and considerable labor was involved. Each time the maintenance cost was at least $1,500 and up to $3,000. Moreover, temporary shutdowns incurred additional losses. The electronic descaler has been used for more than 3 years. Plates of the chillers no longer need to be opened to allow cleaning. Labor cost and electricity were saved, and no longer was there additional losses incurred by temporary shutdowns. Application in a hotel. Using the electronic descaler with automatic chemical dosing equipment could further reduce the chance for limescale to build up and increase the concentration of cooling water, reducing water discharge and yielding better result. Installation of the electronic descaler. After the electrode was placed in the 900 refrigeration ton cooling tower, a large amount of limescale was attached to the cathode net. Application in a frozen food factory. Using the electronic descaler in the evaporative condenser, after operating for several months, hard limescale accumulated at pipes of evaporative condensers, rendering the equipment less efficient and increasing its consumption of electricity. While the steel pipes were coated with a protective layer of zinc to prevent corrosion, And limescale removing chemicals would also dissolve zinc. Only high-pressure washers or manual cleaning could be used. But only limescale on top and bottom pipes could be removed by high-pressure washers. Middle pipes could not be cleaned, and when it's too thick and block the water flow, the whole equipment had to be replaced. To install the electronic descaler, make a 10-inch diameter hole on the wall of the evaporative condenser and place the electrode in the drain pan. View of the limescale on pipes of the evaporative condenser of a frozen food factory before the electronic descaler was used. View of the limescale sucked to the cathode net after a week. Small water clusters generated by the electronic descaler could soften old limescale. The electronic descaler was applied to the evaporative condenser, and 4 months later, limescale on top pipes was seeped through and softened by small water clusters and washed away, and the evaporative condenser was saved. View of the pipes after the electronic descaler was used for 4 months. Application in a plastic product factory, specializing in producing plastic food packaging containers. Cooling towers with 1,000 refrigeration ton altogether. Chemical processing methods were once applied, but the results were moderate. Later, the electronic descalers were used in 3 of 6 cooling towers to solve the problem of limescale. After 20 months of continuous operation, when the cover of a heat exchanger was removed, no limescale could be found on the insides of the tubes, and the original color of the copper tubes could be seen. The result was satisfying. Now the electronic descalers were used in all of their cooling towers. Application in an optics factory, mainly producing industrial safety supplies such as plastic myopic lenses. Before the electronic descaler was applied, the machines often tripped. 3 months after the installation, trip no longer occurred. Application in an ice block factory, mainly producing ice blocks. Limescale reduces the efficiency of their liquid ammonia refrigeration system. Various methods such as dosing chemicals and magnetizing were tried, but the results were uninspiring. Trip resulting from limescale occurred often, and consequently, the machines had to be shut down for cleaning. Later, the electronic descaler was applied, and high-pressure trip no longer occurred. We are dedicated to producing environmentally friendly and energy-saving products and effectively solve all the problems that occur in recirculating cooling water systems.